As the world plunged into a frigid darkness, nature's harmony was disrupted, leaving a trail of devastation in its wake. The onset of the younger Dryas brought an icy grip upon the earth. Temperatures plummeted 20 degrees Fahrenheit, and once thriving landscapes were swallowed by frost. Lush forests retreated, giving way to barren tundras and frozen wastelands. As the relentless cold spread across continents, the impact on life was profound. Animals and plants that once thrived under milder conditions now found themselves in a desperate battle for survival. Plants that relied on longer growing seasons struggled to produce seeds and propagate. The mighty and powerful creatures of the last ice age, like the 10-foot-long giant ground sloth and the American cheetah, ultimately went extinct after the floods, fire, and comet impacts. And if they survived the fires, floods and impacts, it's likely their environment was so devastated that they would die from starvation. Larger animals would feel the effects of this devastation first because they need more food to survive, and they are typically slower to reproduce. Iconic mammals such as mammoths and mastodons were confronted with scarce resources and harsh living conditions. Many species could not adapt quickly enough, leading to population declines and eventual extinctions. 50% of the world's megafauna went extinct during the Younger Dryas period. Rivers that once flowed freely now froze over, forcing aquatic life to find refuge in shrinking habitats. Amidst this turmoil, early human populations had to exhibit exceptional resilience and adaptability. Some cultures such as the Clovis people in North America were almost completely destroyed. Hunter-gatherer communities faced dwindling food sources and the need to cope with a harsh environment. But what caused such bleak and inhospitable conditions around the world? In the video we will explore the most compelling theory on what caused this desolation. The Younger Dryas impact hypothesis. Many researchers are now coming around on the idea that the Earth was hit by a comet or series of comets that altered the course of life on Earth forever. The Comet Research Group is a team of 63 scientists from 55 universities who are studying the Younger Dryas impact theory. This team has been publishing their findings and challenging critics with their own findings. The Comet Research Group believes that fragments of a comet in the Taurus meteor stream impacted Earth in the northern hemisphere. This is a map of the areas where the group has proposed the impact field is. This would explain why North America lost nearly 90% of its megafauna and Africa barely lost any of their megafauna species. One of the most compelling pieces of evidence supporting the Younger Dryas impact hypothesis is the discovery of a distinctive layer of sediment known as black mat. Found at various sites across the world, this dark organic-rich layer contains high concentrations of microspherules, nanodiamonds, and other impact-related materials. These microscopic particles suggest a catastrophic event, possibly a cosmic impact, which contributed to significant environmental disruption. In addition to black mat deposits, scientists have identified several other impact proxies that align with the Younger Dryas impact hypothesis. Widespread soot layers have been detected in sediment records, indicating extensive wildfires and massive amounts of organic material burning. Such fires could have been triggered by the heat and shock waves generated by a cosmic impact. There is evidence suggesting that around 10% of the world was engulfed in wildfire. High concentrations of platinum group elements, such as platinum, iridium, and palladium, have been detected in Younger Dryas boundary sediments. These elements are often associated with cosmic impact events and are rarely found in significant amounts in terrestrial rocks. We see the same impact proxies at the Younger Dryas level as the dinosaur extinction level 66 million years ago. The discovery of high-temperature materials, including melted glass and microspherules, suggests an event of extreme heat consistent with the impact of extraterrestrial objects. The heat was so extraordinary that in some places quartz was boiled. The temperatures seen were also way too hot for volcanic activity. Although no definitive impact crater has been identified from the Younger Dryas period, researchers have proposed potential candidates, such as the Hiawatha impact crater in Greenland. The lack of a prominent crater could be explained by the impact occurring over an ice sheet or an ocean. At the end of the Younger Dryas we see temperatures rise. Could it be that when the comet hit the ocean it sent so much water into the air, it created a greenhouse effect which helped to warm the Earth? The Younger Dryas impact hypothesis gains further support from the synchronized and abrupt global environmental changes during this period. Climate records from ice cores, lake sediments, and cave stalagmites indicate a rapid cooling and fluctuations in temperature coinciding with the proposed impact event. This rapid climatic shift had significant impacts on ecosystems, leading to extinctions of megafauna and disruptions in human communities. Critics of the Younger Dryas impact hypothesis have said if there is an impact, where is the crater? This is a fair question, but the Comet Research Group say that we may be dealing with an airburst where a comet explodes before landing, sending a shockwave of pressure and heat to Earth. They have also suggested that the comet that may have hit Earth was part of the Taurid meteor stream. This meteor stream passes by Earth twice a year, and parts of it could have broken off and caused the damage of the younger Dryas. Critics of the theory also say that Earth couldn't have been hit by a comet because the species did not all die at once as seen with the dinosaurs. However, according to the Comet Research Group, the comet likely hit the ice sheets and heated up the ice to melt trillions of gallons of water. The effects of the impact would be felt for hundreds of years, with a loss of species and habitat for animals globally, but specifically in North America. Some scientists have tried debunking this theory by looking at the younger Dryas layer and the sediment layers and said they did not find impact proxies. However, the sieve they used was not fine enough, and they physically would not be able to detect impact proxies like nanodiamonds. However, further so-called debunkers still use the improper research they did to discredit the younger Dryas impact theory. All of this evidence shows that there was likely an impact along with airbursts globally that set the younger Dryas apocalypse into motion. Conveniently, we see the end of the younger Dryas period as the start of civilization. Could there have been ancient civilizations before the younger Dryas that were wiped out? Unfortunately, we may never know for sure because of the immense power of the younger Dryas impacts. The tale of the younger Dryas serves as a stark reminder of the fragility of our planet's ecosystems and the importance of safeguarding its delicate balance. Let us hope we are not doomed to repeat history and fall victim to another major cataclysm. Thank you for watching. Subscribe for more.